Hi, everyone. I will be introducing our paper, Subverting Fair Image Search with Generative Adversarial Perturbations. On the left, we can see an example search result for the query Professor Style, and this was taken in 2015. We can see that most of the images that are shown are essentially of middle-aged white men with wearing tweed jackets. We know that this is not what all professors look like. On the right, we perform the same query search in 2022, and we see that the search results are a lot more diverse and more representative of the real world. So essentially, fairness is important for image search. Like a real world image search system should not show any unfair stereotypes, but should ideally present diverse, nuanced perspectives. But what happens if there is an adversarial attacker because someone is intentionally attempting to misrepresent themselves or their data? So from previous work, we have seen that the same invisible to human eye pixel distortion introduced into images can cause very different outcomes for people belonging to different groups. For instance, over here, we see that the same invisible perturbation inserted into images of a Black woman and of a white man causes a machine learning model to mispredict the age of the Black woman, but not of the white man. So essentially, in this study, we took this phenomenon and weaponized it. So this is the schematic of our attack. Very briefly, I'll take you through what we did. So on the left, we see an example search result from an image search engine for the query tennis player. And we see that the top 8 images seem to be balanced. There seems to be a mix of genders. There seems to be a mix of skin colors and so on. What happens behind the scenes is that the search engine crawls images from the internet, and we adversarially modify certain images which are also crawled. These images are modified by a model called Generative Adversarial Perturber, which we train to mispredict certain groups. In the given example, the gap actually inserts pixel perturbations to cause a machine learning model to mispredict a light-skinned man as a dark-skinned man. So now both the perturbed images and the clean images go in the image corpus, which are then retrieved by the retrieval model and are then sent to a fairness-aware ranker, which, because the ranker now thinks that there is a quote-unquote dark-skinned man who actually essentially is a light-skinned man, unfairly boosts this person to the top. So this is the harm that's caused here, that a person that did not deserve an algorithmic boost is getting it. To reiterate why this is a convincing real-world attack, I will take you through the threat model. So essentially, we attack a fair image search model that consists of 2 parts: a retrieval step, which is the step that retrieves relevant images when you provide a query, and then a fair re-ranking step, which then reorders the images in that query to get a top list of images that look fair. This fair re-ranking step can either use the labels, the inferred race or gender labels, or it can use the information embedded in the image itself. Now, keep in mind that this is a very restrictive threat model because we wanted this attack to be as close to a real world scenario as possible. So this is completely black box. It's an evasion attack. So the attacker does not have access to the model parameters. The attacker does not know which fair re-ranking model was used by the image search system. So all the attacker can do is they can upload adversarially perturbed images onto the internet and hope that the web scraper will collect these images along with obviously other clean images from all over the web and add it to the repository of images to retrieve from. So this threat model is very similar to clean label attacks or cloaking defenses like from the Fox paper from 2020. And thank you for listening to this talk. And I strongly encourage everybody to read our paper for more details on the methodology and the results and the policy and other suggestions, plus future work that we provide in the paper. Thank you.